Hi guys, in this video we are going to try and understand thermodynamics in physics. In thermodynamics we are going to talk about cyclic process, reversible process and irreversible process. Alright, so these are all PV graphs. Alright, now pressure, volume graph. Initial pressure, initial volume, final volume. Alright, now the reaction, the process begins from A, goes to B, and then again it comes back from B to A. Now see, the path that it takes is the same when it returns back to its original state. Alright, so there's no loss of energy. Alright, now let us go to irreversible process. Now what happens in case of irreversible process? Same thing. Now it is over here. Now, actually we are not supposed to show this. In case of irreversible process, it just goes there and it's not returning back. And even if it is returning back, it's losing this much of energy. It is doing this much of work and losing this much of energy. Alright, so it's irreversible process. I again repeat. Now here we saw that it went via this route and came back again via the same route, not losing any energy. Whereas in this case, it went here and then came back but lost this much of energy. Alright, let me try to explain it with the help of pump that we use for filling air in cycle tire. Alright, now I have pressed this pump till here. So there has been change in volume, right? Initial volume was this much, initial volume was this much, final volume is this much. So there's change in volume, so we have done some work. Now if I intend to bring it back there, if I bring it back fast there, then what happens? There's friction between this piston and wall of cylinder, owing to which there is heat generated, and since heat is generated, so there is loss of energy. Alright, so now see, I push it down here, I come from A to B. Alright, let me put this as A to B. I push it from A to B. So yes, done. When I am coming back with rapidity, owing to which friction is created, owing to friction heat is generated, and heat is generated, that again is loss in energy. Alright, now this is what is the loss in energy. Fine. So irreversible process. Now, alright, it's an irreversible process because there's loss in energy. Now suppose, assume, say we have used, while doing this work, say we have used 10 joules. We have done 10 joules work while moving it from here to here. Now I am taking it up with speed. So owing to which some calories are lost. Alright, now this calorie, you know, there's a conversion factor between calories and joules. So I convert that calorie into joules. And I find that out of 20 joules that I have used for doing the work, 3 joules are lost. So when I come back over here, so 3 joules are lost, and this is what is that 3 joule. This represents 3 joule. Alright, and how do we calculate this? That I will show it over here. Alright, later on. Alright, so we have lost 3 joules. So what is then reversible process? In case of reversible process, same thing. I went from A to B, I went from A to B, but when I'm picking it up, I'm picking it up so very slowly that there is no heat generated owing to friction. There's no friction and no heat generated. So I'm doing it very slowly. Alright, so I'm lifting it up very slowly, so there is no friction between the piston and the wall, and so no heat is generated. Since no heat is generated, so there is no loss, so it is retracing the same path. Alright, do you believe this? It's not possible. Even if I'm picking the piston up slowly, still there would be friction. There would be some loss of heat. So we call this reversible process as ideal process. Alright, it's ideal process. Why? Because it's not feasible. So So reversible process is an ideal process. There is no loss in energy. That is what we assume in case of ideal process. Very slow change, and the path is retraceable. Alright, so what in irreversible process? In case of irreversible process, we can do it fast. Loss of energy is there. It's a real process where we are losing heat owing to friction. Yes, we are. So it's a real process, and the path is not retraceable. Fine. So that's the difference between reversible process and irreversible process. Alright.